Welcome to Savoir Labs. I'm Jamie Goodyear. Today we're going to find out how fast this Snapdragon Windows ARM-based laptop can run LLMs on Ollama. Up next. Reviewing our hardware, we have a Snapdragon X Elite with 12 cores at 3.4 GHz and 16 gigs of system RAM. Before we start testing, let's talk about what we see on the screen. On the right hand side, we see the Windows Task Manager and the information from our Snapdragon X Elite CPU. On the left hand side of the screen, we can see our Windows terminal. Before we start testing, let's just share what we are using for our script. We have a Windows Ollama benchmark available on Savoir's GitHub account. We'll put a link down in the show notes below. Feel free to use it. Now, before we start testing, I want to show you how this script works, and then we're going to show the setup of each one of the tests, and then we're going to show you the results. The reason we're going to have a little break is that when OBS is capturing all this data, there's just enough load on this machine that it affects our output. In some cases, it's quite a lot, so I don't want to be showing you false outputs. I want to show you the closest to what this machine really can do. With that being said, let's run one of our smallest base models and just give you a sense of what this looks like when it runs. This is the Llama 3.2 model. It's a relatively small one and should give us pretty decent values. I'm going to run this first on screen, then I'm going to run it a second time with OBS turned off to show you the difference in the throughput we'll see. With OBS engaged, we can see we got 16 tokens per second. I'm going to stop the recording and rerun this script with OBS off and just to see the difference. We have reran the script and we can see now we are averaging 37 tokens per second. The GPU is not engaged when we are running Ollama on this system, so it's purely a CPU driven result. Let's take a look at our next model. Let's set up our run of the Mistral model. And we're going to stop our recording and come back with the results. And Mistral managed to give us 16 tokens per second. Now let's take a look at our DeepSeek models. We are going to start with our smallest of the DeepSeek models we have, the 1.5B. The 1.5B model gave us really good performance at 67 tokens per second. Let's try the 8B model. And with the 8B run complete, we see 12 tokens per second. Let's try our 14B model. And our 14B model managed to get us 5 tokens per second. Let's have a look at our overall results and compare it to some of our prior test systems. Included in our table above, we have our Dell R250 system with the 8GB A1000 card, the Apple M4 Mac Mini, which was a base model, just 16 gigs of RAM, and our results for our Snapdragon equipped Surface Pro. We want to keep in mind when we're looking at these numbers that this is a CPU only benchmark in the case of our Surface Pro. We did not have the NPU or GPU engaged. Reasons for that is that we need to be able to test on a wider range of GNN or the Qualcomm engine enabled models, things that have been specifically made to be really well ran on the ARM CPU. In context here, these numbers are relatively low, but what is interesting is that we are still getting some decent responses, and we can see with the smallest of these DeepSeek models, we have a pretty decent tokens per second. So if we're trying to build, again, development time with a locally running Ollama model, we can do it within this relatively resource constrained environment. That being said, once we have more appropriate models to run on this platform, it'll be interesting to see what kind of speeds we can get through on it. And with that, we'd like to thank you for joining us on this set of benchmarking on our Windows ARM-based Surface Pro. Please remember to like and subscribe, and we'll see you on our next video. Cheers.